In this section, we will explain how t-SNE got its name. This overview will help you better understand the upcoming video on the inner workings of t-SNE. In this brief video, we aim to introduce the key components of t-SNE and explain what it stands for. t-SNE was invented by Lawrence van der Motten and Geoffrey Hinton in 2008 as part of the broader field of manifold learning. Other methods in the same family include ISOMAP, locally linear embedding, LLE, Hessian LLE, Laplacian eigenmaps, and UMAP, a more recent and often faster alternative. Let's dive into what t-SNE actually means now. Let's first distill the name t-distributed stochastic neighbor embedding. We say t-distributed because it uses the t-distribution, a bell-shaped curve, to measure distances between points in a low-dimensional space. Stochastic just means t-SNE randomly chooses and optimizes neighbors during the process. And the NE stands for neighbor embedding because we represent individual points of data in another space. If the Swiss roll shown here is your subject of study, t-SNE can assist you in embedding the object, often by its different colors, into a lower dimensional space. Let's look deeper into what embedding in the context of t-SNE means. An embedding is a numerical vector that represents an item like a word, image, or user in a way that captures its meaning or how it relates to other items. If an embedding is larger, it could capture more nuance, but it could overfit, and they can be heavier to compute. On the other hand, if an embedding is smaller, it is faster, but it may miss details. In summary, embeddings take high-dimensional data and compress it into a more manageable form while still keeping the meaningful structure intact. To recap, we examined the origin and definition of t-SNE and set up the foundation for us to dive deeper in future videos. If you would like to dive deeper into t-SNE, here are some videos you could watch.